Every night, the moon looks like it's standing still. The same face, the same place, the steadiest thing in the sky. But right now, while you're looking at it, it's leaving, slowly, year after year. The moon is drifting away from Earth, just under 4 centimeters a year, less than the width of your finger. So slow that no one in all of human history has ever seen it happen. And still, there was something to see. The moon isn't going to disappear. It's just leaving, and it's taking more with it than you'd think. This light doesn't illuminate anything. It's just lying there on the floor. It was here yesterday, a little to one side. Last month, further still. It shifts a little every night because the thing that casts it is shifting too. No one has ever called this an event, but that's exactly what it is. For as long as there have been people, they've looked up at the moon and tried to read it. 12,000 years ago, someone cut 12 marks into a bone. He'd noticed that the light in the sky moves in a circle, and that if something repeats, you can count it. And once you can count it, you can predict it. That's how a human being first got a future he could see coming, and it was the moon that gave it to him. Every person who has ever lived has seen it, and every one of them saw the same face, the same markings, held toward us for 12,000 years without shifting at all. And that is not how anything behaves when it's simply hanging in the sky. Anything that spins will, sooner or later, turn its other side toward you. So, always the same side isn't a feature of the moon, it's a trace. Earth and the moon pulled on each other for so long that the moon's spin finally settled and it came to rest, holding one face toward us. For the moon, that's already happened. For Earth, the same thing is underway right now, only slower because Earth is heavier. We watched it for 1,000 generations, and not once did we ask whether it was holding still. There was only one way to ask. Measure the distance, precisely, and year after year. For a long time, there was nothing to measure it with. Then, in 1969, the first people to reach the moon left a panel of mirrors on its surface.
Green light clear, Houston, LA.
Built to send light straight back the way it came. It's still there. And ever since, observatories on Earth have aimed a laser at it. The pulse goes up. And it comes back 2.5 seconds later. The speed of light is known with enormous precision, so those 2.5 seconds are the distance, not a calculation on paper, a direct measurement. And every year, it comes back a little larger, by that same 3.8 centimeters. So there won't be any guessing here about what might happen if the moon vanished. It isn't vanishing. It's moving away. We'll invent only one thing. We'll speed up time to watch in a few minutes what nature takes millions of years to do, because the distance grows every year, and that means something else is growing along with it. And the first thing growing along with that distance is hanging on your wall. The first unit of time wasn't invented. It was copied from the sky. A day is one turn of the Earth. A year, one loop around the sun. And a month is the moon. The calendar on your wall is the oldest instrument in your house. But it has a quirk. Its scale isn't fixed. The day is slowly getting longer by roughly 0.02 of a second per century. You'd never feel it in a lifetime, but by most estimates, the young Earth turned all the way around in just a few hours, and it's the moon that's stretching it, though not in the way you'd think. Earth and the moon pull on each other, And every day Earth hands the moon a tiny piece of its own spin. That same handoff lifts the moon a little higher. The day grows longer, and that's exactly why the moon backs away. One motion, seen from two sides. Just how fast it went in the deep past, we honestly don't know. The pull depends on the shape of the oceans, and those shifted with the continents. The fisherman on the pier doesn't check his phone. He looks up and names the hour the water will pull back. An hour he learned from his father, who learned it from his. His clock doesn't show a number, it shows water. The water climbs to this line and falls away again, twice a day, every day. A tide isn't just the water got higher. It's a narrow band of shore that keeps slipping underwater, then surfacing again into the air. And it's been doing that for 4 billion years, without a single break. Anything that repeats for that long stops being an event. It becomes a condition, the background against which anything else can happen at all. The moon didn't make the oceans. The water was here first. It only made the rhythm wider. And there's a guess, only a guess, not a settled fact, that the border between ocean and land is where life took its next step. Something that learned to last a few hours out of the water wasn't conquering anything. It was just staying where it was when the water left. And maybe that was enough. A child walks across the wet floor where the sea was only yesterday. 6 hours from now, it'll be sea again. What's just a pretty picture in a window for us is a schedule for everything else alive. Once a year, on a particular full moon, an entire coral reef releases its eggs at once, in a single night. Hundreds of kilometers of coral, one moment shared across all of it. And it isn't beauty for its own sake, it's precise timing. An egg lives only a few hours. Let the coral drift apart by even a day, and there's no next generation at all. So they check the time, by the moon. Fish spawn on the highest water, not by the calendar, but by the phase. And through the polar night with no sun for months, the plankton in the deep still rise and fall by the moon. There's so little light the human eye can barely find it. For them, it's enough. So it turns out we read this clock worse than anything else that uses it. And we're the only ones who've learned to switch it off. A person steps out of a doorway, takes out a phone, and turns on the flashlight to reach the car. On a full moon, he doesn't even look up. We didn't move the moon away. We just switched on a light of our own and stopped seeing it. For everything living under that lamp, the moon is already gone, ahead of schedule, by our own hand. The seasons aren't about how close we are to the sun. They're the tilt of Earth's axis, those 23 degrees that let the hemispheres take turns leaning into the light. The moon didn't create that tilt, but the tilt has a property that matters more than the tilt itself. It holds. Year after year, for thousands of years, summer arrives after spring, at about the same time, and there's no guarantee of that. A planet's axis can wander, and when it does, the whole climate wanders with it. Mars, with no large moon beside it, tilted far more than Earth ever has, and it's thought that the moon is one of the anchors keeping our tilt roughly where it is. One man photographed the same tree for 20 years, from the same spot every week, certain the order would return, that spring would come again. All of our farming rests on that certainty. The land only feeds us where we know in advance when the warmth will come. Just how large the moon's role really is, scientists still argue about it, and there's no single answer yet. But one thing is certain: the moon rises by 3.8 centimeters a year. Across a whole human life, less than 3 meters. Nothing collapses tomorrow or 1,000 years from now. And yet, if something keeps shifting one way, that motion has to have an end. The whole exchange runs through water. As long as the oceans move, Earth gives up its spin and the moon climbs higher. But in about 5 billion years, the sun will burn bright enough that the oceans won't be here. Not an explosion, not fire. The water will simply drift up into the atmosphere slowly and not come back. And with no water, there's almost nothing left to give. The exchange nearly stops. And for it to truly finish, for Earth to turn one face toward the moon, the way the moon has long turned one face toward us, would take around 50 billion years. This system doesn't have that kind of time. That's the whole point. The moon won't fly away from Earth. Earth will simply stop giving it the thing that was lifting it all this time. This scenario never reaches its end. Not in our time, not in anyone's after us. It stops halfway and holds there. The line didn't disappear, it just stopped being renewed. The sun is about 400 times larger than the moon, and it happens to be almost exactly 400 times farther away. Two unrelated numbers that happen to line up, which is why in our sky, the sun and the moon appear the same size. And it's why, for that reason alone, Earth has total eclipses. No other planet in the solar system has this coincidence, and it's temporary, because the distance is growing. The dinosaurs never saw a total eclipse. The moon was closer, its disk larger, covering the sun with room to spare. And in about 600 million years, no one will see one either. The disk will be too small. It exists only now. In this thin window we happen to live in. It was here yesterday. It'll be here tomorrow, a little farther over. We're used to thinking some things will always be here. That they're just part of the background, something we don't have to notice. But even the most familiar things in our world are held up by a thin, slow balance, and it's moving the whole time, just too slowly for us to ever be alarmed. The moon isn't abandoning us, it's just reminding us, very quietly, by almost 4 centimeters a year, that familiar was never the same thing as fixed. A world that looks like it's standing still is really holding its balance all the time, just slower than we're able to notice.